Here we are in section 3.4, exercises 10 through 18, and it says to use the following sets of data. So we have birthdays set, we have city average high temps, and we have perfect squares. All right, so it says find the following. Domain of birthdays. So the domain is the first element, the set of first elements. So it would be January, February, March, April, May, June, July, August, September, October, November, December, all as a set. That set constitutes the first element in every single one of these, and that's the domain. All right, number 11, the domain of high temperatures. So if we were to look at the high temperatures for the city averages, the domain, let me see if, let's go from least to highest to make sure we get them all. So we got 59s, we got a couple of 59s there, so 59 is one of them, and then 61. So 59, 59, 61, looks like a couple of 70s, and then 72, 80, 84. 72, 80, 84. All right, so this is the domain of the high temps. Again, that set gives you all of the elements that end up being related in the first column there. All right, number 12, the range of perfect squares. So here, we're going to everything that we hit. So the range is the second set. All right, so if we start from least to greatest, there's 0, and then 1 happens twice, and then 4 happens twice, so 0, 1, 4, 0, 1, 4. 9 happens twice, 9 and 16. Excellent. All right, now the range of birthdays. So birthdays per month, so the range, we're looking right in here at these guys. So it looks like we have a 0, 1, 2, 3, 4, got 2 of those, and a 5. So 0, 1, 2, 3, 4, 5. So we'll put those over here, 0, 1, 2, 3, 4, 5. And that's really all we're doing is picking out the set that constitutes all of those second entries. The domain of perfect squares. So let's look over here, perfect squares. We're going to look at this domain right here, and it looks like, oh, it's nice and in order from -4 up to 4. So we'll write those all out. -4, -3, -2, -1, 0, 1, 2, 3, 4. And there we have it. All right, the range of high temperatures. The range of high temperatures. So here's the high temperatures, and here's the range right here. And so that's, ooh, I'll do a little bit of abbreviation. Atlanta, Boston. So Atlanta, they don't ever double up, do they? So I can just go straight down through them. Boston, Houston, San Diego, Seattle, Chicago, Miami, and Richmond, probably Virginia there. Alrighty, and there we have it. You just listed out everything that was in that set. Good. Now we have the questions down below. Of those 3 sets, name all of them that represent relations. Well, relations, we're actually going to answer number 18 right here. Relation is any connection of data that relates them in any way. So all 3 of them are. All of them. Birthdays, that set, and average temps, and perfect squares. Write that out, perfect squares. Alrighty, that's great. And that's it. All of them are relations. Everything's a relation that connects up numbers or any sets of data. It could be names or months or anything. Now, of those 3 sets, name all of them that represent functions. So what is a function? Let's talk about this. So a relation relates any of them. A function is any relation where each one element in the domain gets mapped to one element in the range. Okay, so that means each element goes only one place, kind of like in bow and arrow, the arrow only goes one place. Even if another one gets mapped to the same spot, we don't ever split or we don't ever repeat domain elements. So of those, let's look. Birthdays, yeah, those months don't repeat at all. So that is a function. You can play the game where you're like, okay, May has exactly one, 4. September has exactly one, 1. And let me see, city average high temps. Well, we noticed when we did this, we had some doubling up. So if I were to say, okay, what about 84? And you're like, yep, that goes to Miami. What if I were to say 59? You're like, oh, it goes to Boston and it goes to Chicago. That is what is not a function. So city average high temperatures doesn't work. Well, -4 only goes there. Do we have any doubling up in this one? No. If you call a -1, it goes to 1. If you call a 1, it goes to 1. No problem at all. Even though they hit the same spot, each element only goes to one place. Whereas here you had one element, it actually went to 2 places. So perfect squares also is, those are the functions. So number 17, the answers are birthdays and squares. Excellent.